as we change the threshold values. Okay, so let me show you the demonstration on how the value of the threshold will affect the hit rate and the false detection rate. So here's the general case of two classes with one D feature vector. So the left figure is the class density multiply the class prior curve for each class. So the black one is class 1, the red one is the class 2. In order to demonstrate a general case, there is an overlap between the two curves. So the figure on the right is the hit rate versus the hit rate versus the false detection rate, which is the cold ROC curve actually. So when we place the threshold all the way to the left, and the two curves like is shown in the left figure, the corresponding points is around 1% for hit rate and almost 0% for false detection rate. So if you mark the point in the ROC curve, the point should be here. So if you increase the threshold toward right a little bit more, then the corresponding points on ROC curve is moving upward along the curve. So at this time, the point moved upward to here. If we move even more, the corresponding points is moving up even more. If we plot the point track on hit rate versus the false detection rate, we can generate this ROC curve. So let me show you this again, so it will give you a better idea to see how this ROC curve is constructed. So I start with the threshold on the left and I move it to the right. In the process, you see the ROC curve is constructed and the curve will looks like this. Okay, so this is the final ROC curve. From the curve, we can see that as the threshold increases, the hit rate is increasing, while the false detection rate is also increasing. But ideally, the best optimization is to find out the threshold that gives the left top corner where the hit rate is 100% while the false detection rate is 0%. That is the ideal case, but in reality, this cannot be achieved. So let's compare the performance of testing or our classifier. So again, in the ideal case, if the distribution of the two classes are not overlap at all, there is a threshold that can make a 100% hit rate and 0% false detection rate, just like the figure on this left shown. But if the distribution of the two classes, the curve, are overlapped completely, in other words, if the two curves are the same curve, the ROC curve will be a straight line with a slope of 1. So that is what is shown in the right hand side curve. So let's look at the regular ROC curve results. Okay, so these are the shape of the most ROC curve looks like. Okay, so most of the time the ROC curves connect the points from 0% and 0% to 100%, 100%. So and the curve shape is a convex curve toward left top corner. So the evaluation of the performance of test depends on how close the curve to the left top corner. So the closer, the better. So from the figure shown here, so the left curve has shorter distance between the last top corner and the curve convex point. Obviously, on the right hand side, this curve has longer distance between the top left corner and the curve convex point. So as a result, we can conclude that the testing that generates the left curve is better than the testing generating the right curve. Okay, so this gives us a way to find the best threshold by looking at the point where you have the shortest distance. So that point, whatever the threshold that make that point happens, that should be your best threshold. So in this case, you avoid estimating the class density for each of the classes. So conclusion. So the RLC curve is used to illustrate the performance of a binary classifier system, as its discrimination threshold is varied. So, and it is useful when find the threshold without knowing the distribution of the two classes. Okay, that is pretty much what it is about the introduction about the RLC curve and how it is derived and how to use it to find out the threshold to identify the two classes without estimating the two classes distribution density. So here are the reference, and thank you very much. If you want to see more lecture, please visit the same website I mentioned in the beginning of this lecture. Thank you. You have a good day.